Let's say you're a mathematician and you spend your days multiplying numbers together, but not any number. You have this particular obsession of multiplying the same number to itself over and over, such as 10 times 10 equals 100, 10 times 10 times 10 equals 1000, 10 times 10 times 10 times 10 equals 10,000, or 10 times 10 times 10 times 10 times 10 equals 100,000. After a while of doing this, you get tired of writing the same numbers over and over again. And because you are a good mathematician, which means you are creative and lazy, you come up with a scheme, creative, so that you don't have to write so much, lazy. Your new scheme works something like this. If you're multiplying the numbers 10 together 4 times, you take the number you want to multiply, write it down, call it your base. Then you take the number of times you want to multiply that number together, raise that number up and to the right of your base. You think to yourself that this raised number is powerful, and so you call it the power. 10 raised to the power of 4. That sounds nice. So now these two statements are equivalent. 10 times 10 times 10 times 10 equals 10 to the power of 4. After a while of playing around with this notation, we decide we can generalize it in the following way. b to the power of 4 equals b1 times b2 times b3 times b4. Wow, that looks great. But what if our power is really big, like b to the 1,000 power? This will never stand. I'm just too lazy to write all those numbers down. What if I just write down the first few numbers, then write dot dot dot, then write the last number? B to the power of 1,000 equals B1 times B2 times B3 dot 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 B1000. Voila, done. Or even better, what if I replace my power with the number n? Then n can be whatever I want it to be. B to the power of n equals B1 times B2 times B3 dot 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 times Bn. Now we have achieved maximum laziness. But you can't tell people, especially your teacher, that you are lazy. What would they think of you? Using your creativity again, you can decide that instead of telling people you are lazy, that you should, nay, must, convince them that your new system is efficient. You will be held as a genius by all. You decide that this new notation system is exponentially better than the old way of multiplying the same number to itself over and over again, and that it needs a new name. And because we love math so much, and we want to talk about our new notation with our math friends, we come up with clever names and decide that when we write b to the power of n, that b will be called the base, and n will be called the exponent. Get it? It's exponentially better, therefore exponent. So we continue playing with our exponents and bases and find a sticky situation comes up. What if our exponent is 0? Well, if our base is 0, this is easy because we know that 0 times anything is 0. So 0 raised to the power of 3 is just equal to 0 times 0 times 0, which is equal to 0. But what about 10 to the power of 0? Well, this is 0 tens, but should we say this is 0? What if we do the following? 10 to the power of 3 times 10 to the power of 0. Isn't this just 3 tens multiplied by 0 tens? If we decide that 10 to the power of 0 is equal to 0, then 10 to the power of 3 times 10 to the power of 0 is equal to 10 times 10 times 10 times 0, which is equal to 0. It would probably be better to say that 10 to the power of 0 is equal to 1. That way, 10 to the power of 3 times 10 to the power of 0 is equal to 10 times 10 times 10 times 1, which is equal to 1,000. So we make a rule that goes something like b to the n times b to the m is equal to b to the n plus m. Nice. And we generalize that b to the 0 is 1 where b is any number. Then what about 0 to the power of 0? Should this be 1? 0 times anything is 0.